Nowadays, everybody is talking about climate change, global warming, greenhouse gas concentrations. Maybe you get curious to have a scientific look at such topics. Maybe you want to know how the climate is changing in your own country. Is it getting warmer? Is it getting cooler? Or is it not changing at all? I will show you how to answer such questions with open source data and very simple Python code. All you need to have is a computer and internet access. You are watching me online, so all you need to have is a computer. Alright, ready? Let's go. I have put the Jupyter notebook or the code on GitHub, where you can share your codes with others or other software developers or colleagues, and you can have a track of changes of your project. If you want to know more about GitHub, please go to Udacity GitHub and collaboration free course, and become a profi in GitHub within 3 weeks. I will put the addresses in the comment of the YouTube. So here you can easily download it through the click, or you can clone it in your terminal. What you do is just write clone GitHub and the link, and you're gonna have the whole folder in your window there. So now I'm gonna open my Jupyter notebook. So that's the code. Where I have downloaded the data is, I have downloaded data from the Berkeley organization. Here you can download a lot of free climate data. And then I just go straightly to the code. Here I import the libraries, pandas, matplotlib, numpy, and some input-output libraries. Here I read the data from the website and put it in the Panda data frame, and here's some data cleaning, and at the end I have a very nice data frame containing year, months, climate anomaly, temperature anomaly, and the uncertainties. What does the anomaly mean? The data is provided as temperature anomalies with respect to the average of 30 years, because climate means 30 years average of the weather at least. So that's why you calculate the anomaly to 30 years of climate average. So we want now to go and plot data. I have written a very simple function here, which takes as input the year, temperature, uncertainty, and the title. So I produce the years because in my data the years are repeating here. So I want a very nice label for my x-axis. So I put it, call it years, line space between year minimum, year maximum, number of my data points. Here I make a bigger figure in my Jupyter notebook with this size, resolution, face color, edge color. And I plot year against the temperature with the red color, and plot the years and the uncertainty with blue color, and put some x and y axis label. And running our function, you can see here a cloud of data. Blue is the uncertainty, as you can see at the beginning of the recording of temperature in the United States. We didn't have that much of observations and stations, that's why the uncertainty is very high. And now after 1900 we have a good uncertainty, or the data is very certain, around 0. and you can see the anomaly of the temperature. If there, you can see that most of the maximums are happening after 2000, and we have some extreme cold conditions as well. Now the problem is the trend is not that obvious here, because there's a lot of data plotted in one figure. So what we can do about it? One very easy, simple solution would be using a moving average or running mean or rolling mean, whatever you can call it. What does the rolling mean does is it takes just one point. If you choose a window of 30 months, it takes for each month an average of 30 months near neighbors of that month. So 30 months before that point and 30 months after that point, and makes a mean of that. So if you look at the moving average right now, you can see there is a much difference between these two presentations. So this visualization is much understandable, much more understandable than this one, because you can see now the very nice uprising trend from 1900 in the United States with a good uncertainty. So the climate is warming. To have a better feeling of this shift of the climate, we can go for histogram plots, which can show the frequency of happening each temperature value in the history. For that, I have chosen 3 different climate periods of 30 years. The first one, I plot the monthly temperature for the years greater than 1983, because the last of my record is 2013, so that would be 31 years average. And I show it in the red. I put a label on that, and I just want to see the lines of the histogram, because I want to plot 3 periods, so then it's gonna be very busy and I cannot see the shifts very nicely. So the second period is between 1983 to 1953, and the last period 1953 between 1923 and 1953. And I put some labels, X and Epsilon, and a title containing the country, because at the starting of the code I could choose also other countries. But now I'm showing the United States, but because the topic is very hot there. So if I plot it, now you can see some very interesting patterns in the data. Very early periods, 1923 to 1953, the blue line, you have one maximum, a very nice Gaussian distribution with some extreme cold periods, and the maximum frequencies are around 0 anomaly. So 0 anomaly. And the next period, 1953 to 1983, you have also a Gaussian distribution, and the maximums are just around 0. These extreme cold periods are also shifting to warmer periods, but still it's Gaussian, and the maximums frequencies are happening around 0. But if I go to the last period, 1983 to 2013, now the game has changed. You can see I have 2 maximums, actually 3, the little one, which are happening at 0 degree, and the other peak, which is as large as this peak, is happening at more than 1 degree Celsius. And the third peak is happening also around 1 degree Celsius. And I have some strange, warm, extreme events, which is happening at around 4 degree, plus 4 degrees Celsius. So you can see the climate shift very significantly in this histogram plot, which might not be that obvious in the line plot. So choosing different kind of data visualization is gonna help you to understand the pattern inside the data. So just for fun, I'm gonna change the country to Germany, where I live now. You still see the shift, the second maximum again, and you can see the warmer periods are getting more frequent. It's like that. It's like as if the Gaussian or the distribution is moving to the warm climate. Thank you very much.